Section 8.4 is going to be about solving quadratic equations again. We've already done a lot of these type of solvings with terms of factoring and substitution, but now we're going to look at where we don't have integer answers. We could have irrational answers. We could have imaginary answers. How do you know if a polynomial is factorable over the rational? Well, you're going to know it is if the discriminant is a perfect number. So if the discriminant is not a perfect number, then the polynomial is not factorable. So if it's not 1, 4, 9, 16, 25, and so forth, then it's not a factorable polynomial. So, and that's for quadratics only, obviously. So if we look at this one, it says, can the following polynomials be factored? So we're going to look at just the discriminant. So all we care about is that the b squared minus 4ac. You're going to do 5 squared minus 4 times 3 times -1. So 25 minus 4 times 3 is 12 times -1 is -12 minus is a positive 12. And so you're going to get 37 here. So 37 is not a perfect number, so that means this is not factorable over the rationals. Number 2, if we look at that, you do b squared minus 4ac, and so you get 9 minus 4 times 2 times -5. So you get 9 minus -4 times -5 is 20 times 2 is 4, so 9 plus 40 is 49. And so this would be a yes, this is factorable. And so you could proceed with factoring. This one here, you would have to proceed with either completing the square quadratic formula or something different in terms of solving it. So let's just go ahead and solve some of these different quadratic equations, and just to remind us how to do that, and looking at them over the irrational as well. So for this one, if you remember this one, we did this one very similar to this one. We did solving quadratic equations a couple chapters ago. And so I'm just going to let x equal that m plus 3. And so you're going to plug in x for m plus 3. And so you get something like this is equal to 0. And so is that factorable? Are the factors of 14 that -14 that add up to be 7, positive 7 and -2? So this be x plus 7, x minus 2 is equal to 0. And so you get, in this case, you get x equals a -7 and x equals 2. And then, but remember, we're not done here. And so we're going to take those two values and plug it back in up here. And so we're going to take these and plug it in to what we originally substituted. So we're going to say -7 is equal to m plus 3. And so -10 equals m. So that's one of my solutions. And 2 equals m plus 3. Subtract 3, you get m equals -1. And so that's my other. So my solutions to this are -10 and -1. Another example, same idea here. It's going to be a substitution problem. Might not come out as nicely as we saw though before. And so if we look at this, we're going to go ahead and let y be 2x minus 1. And so you're going to get y squared minus 4y plus 2 is equal to 0. There are no factors of 2 that add up to be -4. And so you're going to go straight to either completing the square or quadratic formula here. I'm going to do completing the square since this is already a 1. So you get y squared minus 4y is equal to a -2. Half a negative 4 is 2. 2 squared is 4. So I'm going to add a positive 4 to both sides. And so I get y minus 2 here. And -2 plus 4 is 2. And square root both sides. You get plus or minus root 2. Add the 2, you get y is equal to 2 plus or minus root 2. So that's only y, remember. And so now we have to take this value here and plug it in back up there. And so we're going to get, so we get 2 plus or minus root 2 equals 2x minus 1. Add the 1. You're going to get 3 plus or minus root 2 is equal to 2x, and divide by 2. So you get 3 plus or minus root 2 over 2 is equal to x. You know, that's what the plus or minus, but you do have to be careful here because it can affect your answer. But in this case, it does look at the answer are 3 plus or minus root 2. And so this is your answer to this problem. And you could separate that out if you really wanted to. 3 plus root 2 over 2 and 3 minus root 2 over 2. I don't care if you do or you don't. Okay? Next example, x to the fourth minus 20x squared plus 64. This one here, we have an x to the fourth. Again, we saw these before, so this isn't something we've not seen before, so this is kind of just a reminder. But just a reminder here, since we need it to be x to the fourth, we're going to let y be x squared. And the reason is because it's a smaller, but also because if you square y, you get x to the fourth. So that means that over here, I can write this as y squared minus 20y plus 64 is equal to 0. And then check to see if that's factorable. This one is indeed factorable. Factors of 64 that add up to be negative 20 or negative 16 and negative 4. And so you're going to write it y minus 16, y minus 4 is equal to 0. And so you get y is equal to 16 and y is equal to 4. That part is not new, but it's when, well, this other part's really not going to be new either because you're used to this one. But so now you're going to take these and again plug it in up here. So you're going to plug it into that y equals x squared. And so you're going to 16 is equal to x squared. X then is equal to plus or minus 4, right? Because the square root is 16. And 4 is equal to x squared. And so x is equal to plus or minus 2. And so your solutions to this one are negative 4, negative 2, 2, 4. That one's something you're actually used to. And now this one here has fractional exponents. I don't remember if we looked at one of these or not before, but again, we're going to do substitution, and I need you to fix this. This should actually say y squared, and this should be y to the fourth, because I want 1 to the fourth is smaller than 1 squared, 1 over 2, because I'm going to let y is equal to x to the 1/4. And that way, y squared is equal to x to the 1/2. And so over here, we can say that this is y squared minus 3y plus 2 equals 0. Again, factorable, y minus 2, y minus 1 is equal to 0. So y is equal to 2 and y is equal to 1. And now we're going to plug it back in, these back in to that top one. And so we're going to say 2 is equal to x to the 1/4. And we need to fourth root both sides. So we get 16 is equal to x. And we also get 1 is equal to x to the 1/4. Not fourth root, but raise everything to the fourth power. So you get 1 is equal to x. And so in this case, your answers are 1 and 16. All right, and you really should check those because that 1/2 and that 1/4 are actually even roots. And so you want to check to make sure they actually do indeed work. And again, this is the only time you need to check that. Okay, so go ahead and do the true false, and then we'll start here. You do not need to worry for now about numbers 7, 8, 9, or 10. So just do the true false 1 through 6 for me, because these are word problems. We'll come back to those eventually. Have a good night.